Okay, let's get to the last talk of the evening. Yes, it's there. Rafal from OpenPeer is going to talk briefly about, not briefly, 25 minutes or so, about running AWS in Enterprise. Just before we get going, if you go to there's a relatively active Slack channel, Serverless forums, lots of people all over the world on it. There's quite a few AWS, IBM, Microsoft Azure people on it. Serverless forum. If you go to the serverless.london website, you can sign up to the Slack channel. So yeah, get on there, join the chats. If you ever have any questions, there's lots of people there who'll easily be able to answer your question throughout serverless. So get on there. Another thing that's coming down the line is the Serverless London GitHub organization, which I'm going to publish the code for the Slack invite, and there's a Google reCAPTCHA on there. But if you guys have any code you think anyone might be interested in, we can publish it on there as well under that organization, or we can just promote it through the organization. Anyone open source. I can't think of anything else. So after this, we'll just go straight to the pub, and yeah, that's the pub.
Hi everybody, thanks for sticking around. My name is Rafal. I'm a lead consultant at OpenCredo. OpenCredo specializes in helping companies large and small to use cloud computing. So under different sort of guises, obviously infrastructure as a service, containers, and obviously lastly but quite importantly, I think in the context of this meeting, serverless. So today I want to talk about serverless in the enterprise. And you know, the problem I pose is that, so like, yes, I get that all of you want to use serverless, or that you are already using serverless, and I bet you've got different reasons to do so. It's obviously fairly new and emerging area, but also there are some substantial economical reasons that people might want to have serverless over using servers or containers. But then, you know, you might be working for an enterprise type organization, which favors solutions that are, you know, highly secure, operable, well supported and compliant, or perhaps you just want to build something more substantial and just a small lambda. You might want to have multiple development teams supporting your platform. You might want to use CI, CD, or the best DevOps tools, automated testing, you know, microservices, event-driven architectures, all the good stuff. So I guess what I want to talk about is actually building something more substantial on top of serverless stack, primarily on AWS. So imagine you've got a simple use case. You know, let's say you want to build a chatbot. It doesn't render very well, but you know, let's say you can put it together by some API gateway, API handler of some sort, and then you can you know, respond to some API calls from Slack or some chats. Or let's say you want to create an image resizer. You can hook it up fairly easily. Maybe you want to do the direct upload to S3. Maybe you want to actually enable API in front of it. Either way, it's fairly straightforward use case. It wouldn't take long to implement it. You can do it fairly easily with serverless. But now imagine that, you know, you've got a slightly bigger problem to address. You want to build a, you know, API first platform for a cloud management provider. We are talking tens of APIs, bunch of different components. You want to perhaps have some components doing, you know, implementing CRUD operations or specific data. You've got certain things that are scheduled or triggered in the background. You've got some event-driven processing. You are obviously quite conscious about security requirements in the enterprise environment. You perhaps have to work with some legacy systems. You want to use fairly mature CI/CD approach. You want your solution to be, you know, easy to operate. You want to provide sufficient tooling. So how do you go about doing all of that on top of serverless? One thing perhaps you should avoid is introducing something like a serverless monolith. Obviously, if you heard about microservices, you might have heard about the dreaded monolith that microservices are going to replace. But I think the natural approach perhaps towards building something more substantial on serverless would be just trying to add more and more things to a single application And then you might end up with, let's say, tens of different lambdas, some APIs implemented on top of it, a bunch of other resources, SQ buckets, DynamoDB tables, whatever else you can throw into it. And then what you end up having is, essentially a serverless monolith. So you will have a lot of tight coupling, some web of dependencies. You will have to deploy it as a single unit. You will have some challenges coordinating between different teams. So when I was thinking about actually, me and my team, about implementing more substantial system on top of serverless stack, one thing that we sort of came to agree is that we need to have a more modular approach towards structuring our system. So with that, I sort of coined the term serverless components. You can think about this trying to do microservices on top of serverless stuff. It's not very different from what Dave perhaps was talking about in the previous talk. But the idea basically is to have a bunch of components, each having its own infrastructure stack. So maybe this is somewhat different because I think Dave was explaining that we have a common infrastructure stack. But what I'm proposing, you can notice a Terraform logo there, having a separate stack for a single component, and that's usually scope around specific domain context. If you've heard about domain-driven design, it's very much inspired by that. And then, you can actually establish some consistent naming of resources. You can have a dedicated view deployment pipeline for each of those components. You can have, few lambdas, other resources. You can have an API that it exposes. But obviously, that's kind of optional. You can actually publish some domain evidence to have data disseminated and broadcast between those components if there are some interactions, asynchronous interactions between them. And you can have some components listening to the events from other components to keep themselves up to date with whatever's happening on the platform. So obviously you might imagine that there are some integration patterns perhaps emerging in this sort of setup. It might be that you've got a component that maybe exposes an API, and then it happens that this component has to talk to some other component because there is some follow-up work that needs to be done. So one approach towards that would be to have just a synchronous call from this component to another component using perhaps API gateway and a public HTTP, publicly available HTTP endpoints. The other option is to use direct Lambda invocation, that we've seen some examples of. I think that the downside is that obviously you have to kind of wait for the other component to accept and process your request, and you pay for the wait time. That's definitely on AWS. So maybe it's not great, but sometimes you actually want to wait for something to happen and and be certain that the data has been persisted, for instance. So you don't really have much choice. You have to just pay for all the milliseconds actually spent on waiting for something to happen. The other approach might be to actually use something like SQS or SNS or Kinesis actually to just raise an event, to publish an event, and use the messaging infrastructure to deliver it to just one component, maybe multiple components if you use public subscribe. The good thing about it is it's fairly decoupled. One thing to maybe watch out is that you don't want to end up having too strict or inflexible message formats. Otherwise, you might end up breaking this integration if you end up having to evolve the messages or the events being actually sent across. Another sort of variation of this is that you want to actually publish some events from one component, and you want to have multiple components subscribing to this information. So a good example is, I think that's sort of mimicking something that, for people who are aware of domain-driven design, there's this concept of domain events. So then you have a bounded context producing some events, and then any other component within the infrastructure can actually subscribe and react to those events. So again, in here you have to take care of making sure that the message formats are fairly flexible. Another thing perhaps to consider is APIs, right? We know that all the major providers expose some ways of your serverless applications delivering or implementing HTTP endpoints. Swagger or Rafal are great for actually explaining what the definitions of those APIs are. Then you can use those definitions to automate testing perhaps, or just purely for documentation. Ideally, you would have some sort of developer portal that actually provides documentation for anybody that want to consume those APIs, even internally or externally. Now I guess I'll be talking a little bit about what Dave has touched on. So no surprises perhaps. We are using very similar stack, and that's to do with the fact that we knew that we wanted to go beyond having this maybe a single component, or maybe trying to avoid getting ourselves into a situation that we have a single stack that has to be deployed all at once. So what we are using is a combination of Apex and Terraform with some Python providing the new code, and we have a bunch of build deployment jobs running on Jenkins using Jenkins pipelines. I'll talk about it a little bit more later. So then obviously we deploy across a number of different environments. We've got a separate account for environments, so similar pattern. So with Jenkins and Jenkins pipeline, what you can do is actually you can describe the entire pipeline flow from the build process, which might be running your tests, for instance, and then the deployment. So as I said, we use a combination of Terraform and Apex as the deployment, but we have a separate pipeline for every single deployment within our architecture. This one didn't actually go all the way to production, but we are trying to push towards continuous deployment. So the idea is that with some validation and quality gates, we are hoping to push every single change, so successful merge of the PR branch, of the PR, all the way to production. In terms of infrastructure provisioning, as I said, we are using Apex, and we are using Terraform and some custom Python. So I think what we've discovered is maybe Terraform is not supporting, for instance, dealing with having multiple stacks and interstack dependencies very well. So we built something that actually extended somewhat. But eventually what we want to get to is be able to actually have Jenkins as our CI server to be able to do deployments into a number of different environments, each in separate AWS account. We use remote state with Terraform, so we have a S3 bucket for every single component within our platform, and we have therefore quite small and isolated Terraform stacks, which actually helps maybe aligning infrastructure deployments with code deployments. And for code deployments, because we are predominantly using Node with ES 2015, so fairly recent, but still on AWS Lambda, so as you can imagine, we have to transpire it to an older version because Lambda is still a bit, on a previous version of Node. We are using Babel, and we are also using Wallop, which actually helps limit the actual artifact being deployed to the bare minimum of code, and that saves a lot of space. And then we are using Apex, so obviously, perhaps know quite a lot about Apex by now. I won't be getting into details of that. For testing, we are using a combination of unit testing that we run either locally on CI and sort of acceptance as smoke testing. We've created a custom acceptance test framework where we can actually set up the entire platform to a known state and then exercise certain behaviors. We want to use the same approach towards running smoke tests after we actually deploy to higher environments. In terms of the toolset for testing, we used Mocha and Chai and Sign-on. So Mocha is for unit tests or PDD. Chais for assertions, Sinon for mocking, studying, proxy queries for studying out external dependencies. It helps working with AWS SDK, for instance, which is notoriously difficult to unit test. We actually ended up building a Rafal layer in front of AWS SDKs because we wanted those SDKs to have promise-based interfaces, and sometimes they're actually overly complicated for a lot of specific use cases. We usually use them in very simplistic manner, quite commonly, so we wanted to optimize for our common use cases. Then for acceptance testing or small testing, we use a combination of Mocha and our sort of bespoke framework that through using our own APIs can actually bring the system to a known state and then exercise certain functionality around it. For security, obviously, very important in the enterprise space, and Dave has been touching on it a lot. We obviously wanted the solution to be relatively secure. We don't want some credentials flying around. We want to adopt least privilege policy based on IAM roles, so you can guarantee that your lambdas or other resources have the minimum level of access required to actually do their job. We are using a combination of IAM credentials, STS, for operation or tooling access. So I certainly agree that using instance roles would be ideal for gaining access from the CA tools to the actual environments of the infrastructure. We are sort of somewhat forced to use externally hosted or maintained Jenkins servers, so we have to use IAM credentials for that. But otherwise, we actually were able to hook up our SAML-based enterprise SSO to use AWS STS. So the operational staff is actually using their own enterprise credentials to get access to AWS, which actually helps quite a lot. We try to limit the degree of access that developers have. So we actually have a sandbox environment, which is the only environment that the developers have write access to. Other environments is read-only, stage and production are only for the credentials or keys, and obviously encrypting things both in transfer and in storage. And I guess these other resources are actually allowed to do so. What helps also is to have some common patterns and conventions, so then you don't have to kind of have developers trying to work out how to write those policies. A lot of things that we actually do around lambdas and general sort of defining policies is fairly convention-based and sort of industrialized to make it easier. As I said, we are using a combination of IAM and STE for operations stuff and CI/CD access to our environments. We also have sort of developed a number of fairly bespoke solutions because we have another application we have to kind of share our application session with. We build a bespoke SSO solution. Longer term, we are thinking about using SAML SSO, maybe with JWT token, but it's not something we implemented yet. For authorization, we sort of built a custom authorization library. We very soon discovered that our requirements are perhaps not easily addressable using, let's say, custom authorizers that AWS API gateway provides. So we actually ended up doing our authorization application logic inside of our lambdas. All of that is kind of nicely wrapped out, so we don't wrap up and provide it for various libraries we created, so we don't necessarily worry about it. It's being taken care of. We usually use encrypted objects in S3 for any sensitive configuration values. We don't actually have too many of them because we wanted to go full serverless. We really shun on servers. We don't want to have any servers running around. So we are kind of fortunate we don't have to authenticate the data if we are using DynamoDB or S3 or Elasticsearch, which are very well supported by AWS. So it's sort of IAM access only. But we actually do have one use case for storing credentials, and that's for the fact that the platform is actually integrating with provider APIs because it's doing cloud management. and for that we build a bespoke serverless solution based on dynamic cases. Another interesting aspect, I think, in any larger scale solution, larger scale architecture is logging. So that's not actually very dissimilar from what Dave was talking about. We sort of combined number of libraries. So Banyan is a great library that actually can format your standard output, actually maybe not standard output. So as you perhaps know, AWS Lambda just captures standard output. But if you happen to actually produce standard output that is already JSON data, then you can actually, with some help from more Lambda, serverless goodness, you can actually stream those into Elasticsearch, and then use Kibana actually as a browsing application for this. So this is pretty much what we've done. We've actually even implemented a bespoke log filtering solution because we found out that AWS has got some limits in terms of how many filters you can actually submit. For monitoring auditing, we're using obviously predominantly CloudWatch with various metrics, but also we built a sort of a bespoke operational dashboard that actually uses a combination of CloudWatch metrics and our log filtering solution to combine the information about possible errors or other situations that we might want to react to. CloudTrace being used for auditing. Tooling, we've built a bunch of tools. I think there's definitely more to come. So one interesting one perhaps is we build ourselves a serverless API registry, because we can. As a combination of S3 Lambda and API gateway, we have a lot of Jenkins pipeline DSL based Ruby code to orchestrate our deployments. We build ourselves a bespoke deployment framework, which is sort of the one that actually glues Terraform and Apex into something that you can use seamlessly. So the Groovy pipeline scripts are actually calling this Python framework. And as I said, we build ourselves an operation dashboard. Actually, one thing that I didn't mention here, we recently built ourselves a sort of like a resource inventory, because we've got some stuff that maybe earlier we've sort of stopped being deploying things by hand, and now we have resources that we are not sure whether they should be there or not. So after a while, you want to make sure that what you've got in your environment is actually what is supposed to be there. And certainly using Terraform or other means of actually managing infrastructure helps there a lot. A few lessons learned, just to sort of leave you with that. Obviously, well, no surprises there. Serverless is very new, right? So expect some pain. Changes rapidly, a lot of things going on. I mean, it's like we are not even keeping up with Terraform deployments. They're all new version every week, so I think we are a few back. There is some degree of dependency on SDKs and tooling, provider support. It's great that we are looking at having like provider agnostic serverless, but I think it's still early days. And even if certain interfaces or things can be abstracted away, there will be a lot of provider-specific functionality that perhaps you cannot easily move over. So I think the same thing is happening with IaaS and resources that actually require you to provision capacity, and certainly doing dynamic capacity scaling actually helps quite a lot. Otherwise, you end up being throttled, and you certainly don't want that in production. Serverless frameworks are great, but then I think at the scale that I'm talking about, they quite slowly are actually more of an independent that actually help. And obviously, yes, tooling is still not very mature, so expect to write a lot of stuff yourselves. Thank you very much. Any questions? Yes?
How do you take down your environments?
Yes, so I talked about this sort of little environment inventory, resource inventory work that we are doing. That's sort of a prelude towards being able to tear down environments. And I think my personal idea around it would be that I want to be able to tear down our lower environments and sort of start from scratch. The high environments, obviously, you cannot actually turn them down. So one of the hopes that our entire deployment pipeline will be able to do is to validate that the component can be deployed from scratch on the entire environment that we actually brought up from scratch. But also I think we'll be using maybe let's say a testing environment to prove that it can be incrementally updated as well. So because we are using Terraform, we do Terraform plan. So if the Terraform plan tells us that no infrastructure has changed, we basically skip apply. And we only use Apex Apex will tell you that nothing has to be deployed too. So we are trying to be actually quite cautious about not having to change things if they don't have to change. But at the same time, we want to make sure that we can, if the situation arises where we have to actually bring something from scratch, we want to be in the position that we can do that. So the goal is definitely to be able to tear down everything and deploy. As I said, with this sort of component-based approach, obviously component interdependencies will make it somewhat more difficult. But I'm hoping that with Jenkins, we'll be able to orchestrate actually spinning up entire environments. Right? Another question? Yeah.
So, can you dig down to logging? In terms of logging, do you use the Elasticsearch service and ship your CloudWatch logs, or do you use Logstash? I didn't see Logstash there. Do you have
we use Elasticsearch service. Sorry, right. I didn't mention it. Well, the solution that we've done is kind of your serverless-ish, ELK stuff. So instead of, obviously we're using a managed Elasticsearch, right. We use Kibana that is kind of bundled with Elasticsearch. We actually had to, AWS doesn't secure Kibana access, we have a server that is actually a proxy in front of Kibana for secure access to Kibana instance. Right. But I'm hoping that they're going to actually close this loop and secure the access to Kibana. So the sort of Logstash element is basically a combination of CloudWatch logs. So the collection is kind of done for you, but if you want to do something more interesting with your log data, you have to ship it out. So you have to subscribe to various log streams and then have a Lambda perhaps stream it over to Elasticsearch, which is what we do. All right, more questions? Yeah.
Yeah, most of the time I saw like whether online or here, like serverless is like image processing or just chat. But my requirement is, let's say I have 100 applications which is doing scraping of all over the world for mobile devices.
Okay.
And it is storing into one central server, which is S2 server, and I have a lot of tables. I can't merge those tables into that only. So my question is, like, say, on one of the problem I have, I need to schedule one machine, all these 100 applications on one, and whole 24 hours. Yeah. Okay. If I spin up a large system, it will cost me. So I want to replace only web part or a picture part, and keep my database as it is. So can I achieve this only with app part with Lambda, and how I will know this? I will say, okay, 120 MB is required for each application first, and how I will know it will finish its job and it will terminate like that. So is it a possibility combination of serverless plus maybe database?
Yeah, I mean, this is what I think Dave is using. I don't know what sort of database you're using, but it's not something that is Postgres. On like a managed Postgres on AWS. I mean, it's not very different from actually having a database somewhere else. So yeah, I think it's definitely possible. If it's kind of interesting because serverless can be used for a number of different things. Actually, it's amazing what people kind of end up doing. I actually want to maybe blog or write an article about it because there are some use cases that you would never have guessed that can be actually done, keeping all the constraints. So I think if you need some things done that actually are very quick to execute, maybe that's your use case. And maybe you do it quite frequently, and you don't want to actually spend a lot of time on having servers, sitting there being idle, serverless, or Lambda, other function as a services might be something for you. So it doesn't actually matter if you happen to be calling to the database. I think that the caveat obviously is whatever it takes you to wait for the result to come back, you're paying for the wait time. So as long as you can kind of calculate that it's not going to cost you too much, and actually there is a hefty free tier on AWS and other cloud providers, maybe you can actually run it for free. Right? Any more questions?
Yeah. Talking about cost of running the M&E comparison inside, like for example, doing what you're doing the normal servers and instances corresponding? Or there's been some interesting numbers by money.
Not at the moment, actually. We've been doing some basic calculation because the core of the system, once kind of finished, will be doing a lot of continuous processing. So that's going to be certainly interesting use case for serverless or functional service. And I think should be cheaper. But I'll tell you in a year's time. I think one thing to point out is that, like Lambda, for instance, Lambda invocation, we actually do analyze our environments. We haven't got that much, we are not actually running in production at scale yet. We are ramping up. But in the lower environments, Lambda is sort of tiny. Maybe because we don't actually have that much traffic. But the biggest contributors are DynamoDB, Kinesis, for instance, and Elasticsearch. It's mostly because we have to run either servers or we have to provision capacity. So I would actually say that maybe the compute, and it's perhaps meant to happen. At the moment, I think it's still like providers want attract people to serverless, so you have like millions of invocations for free or however many gigabyte seconds or whatever the unit is. And obviously other like IoT platform on AWS, you have hefty free tier. So it's definitely worth playing with that. And actually a lot of services have got free tier, so it's not actually exclusive to just Lambda. But you do your math, right? And obviously it really depends on the type of the use case that you've got. In most cases, it might be cheaper for you to run a micro instance, for instance, if you have enough to keep it fairly busy. But at the same time, maybe maybe it's pretty tiny anyway. So it really depends. What I can tell, like not everything is super trivial, and I think with what we are doing on the project I'm working on, we are pushing it a bit beyond the usual set of use cases, which is obviously very exciting. But that's why I wanted to share my experiences because it's still early days. So don't try to build like a massive system yet, unless you are great.
Yeah.
One last question.
So just to add to that from experience, from kind of my previous company, we save like 80 times, and the way you think about cost is very different from Lambda. It's like think about the time that you're not running your code. That's the savings. The savings is about when you're not running the code rather than when you're running it. So if you've got infrequent jobs, workers that are sitting in the background doing very little all the time, you can save a lot more money.